All right, let's go over homework 1.6, number 5. All right, so this function is given using absolute value sign. When you have an absolute value sign, it is really a piecewise defined function. So let's write it as a piecewise defined function. All right, so this is equal to. All right, so absolute value sign does differently when if x is, say, if x is less than 2. Right? So let's say x is less than 2. Right? 2 minus x is going to be positive, so absolute value sign doesn't do anything. So which means that this is same thing as 2 minus x over the same thing. So it's going to be just 1. Right? How about if x is greater than 2? Right? Then if x is greater than 2, 2 minus x is going to be negative. So what absolute value sign does is to negate 2 minus x so that it becomes positive. So it's going to be a minus parenthesis 2 minus x over 2 minus x. So quantity 2 minus x's cancel out, which means that you're going to have just a negative 1. All right, so this is just a piecewise function, and it's a fairly simple graph. So let's sketch the graph so that we have some idea. So draw the x-axis and the y-axis. Right, and here's the origin. All right, so when x is less than 2, so here is 2. X is 1, so it's going to be a horizontal line all the way up to x equals 2, but not including 2, right? So it's 1 right here, right? After that, it's going to be negative 1, so negative 1. So you have a horizontal line starting from 2, not including 2, so you have a negative 1, right? So this is the graph of f of x. Then we can answer these questions. Describe the intervals on which the function is continuous. So you can see that it's continuous right here. There's no breakage. The only breakage happens at the x equals 2. And other than that, it's okay. So we're going to draw 2 intervals. So it's going to be negative infinity all the way to 2, right? And also 2 all the way to positive infinity. So it's all real numbers except for 2. All right, and another question, identify any discontinuity. So you can see that discontinuity is x is equal to 2. All right. Then if the function has any discontinuity, in this case it does, and we have to say why this is there's a discontinuity, right? Let's look at it. There is a discontinuity at x equals, in this case, 2, where f of c is not defined. So f of 2 is not defined, so we know that this applies to our situation, right? And there is a discontinuity at x equals 2, where limit of f of x is not equal to limit of f of c. Right? We have to be careful. This means that we do have limit of f of x, and we do have f of 2, but we don't. So this doesn't apply to a situation. Right? The second one, there is a discontinuity at x equals 2, where limit of f of x as x approaches 2 does not exist. Right? So this applies to a situation because if you're coming from the left-hand limit is going to be 1, and if you're coming from the right-hand limit is going to be negative 1. So one-sided limits give different values. Therefore, the regular limit does not exist. So this applies. Last one, there are no discontinuity, so that last one doesn't apply. All right, I hope that this was clear.